Hello and welcome to the first lecture in the OxRAM Robot Arm software lecture series. My name is Jacques. I'll be your lecturer for this lecture course, and today I'm going to give an introduction to ROS and Linux. So for today's lecture, we'll first give an overview of ROS, the robot operating system, and why it's important. Then we're going to be giving an introduction to VirtualBox and then Ubuntu, which we'll need to use in order to be able to play around with ROS and use it for developing robotic systems. And finally, we're going to give a brief introduction to the command line, which is going to be very important for robotics software development. Now, before we begin, I really recommend becoming familiar with the following GitHub repository. It's the repository for the Robot Arm project. This directory marked in red in the GitHub repository, you'll find the lecture slides for all of these lectures and all of the example scripts. So I really recommend having this on hand because it means you can refer to them while I'm explaining stuff and while I'm demonstrating stuff to aid your learning experience. Now, what is ROS? So ROS stands for the Robot Operating System, but it's not really an operating system. It's a framework that allows us to manage the complex systems that you find in robotics. Because a robot is usually more than just one program. You often have many different programs, each handling a very different, important part of the robot's function, and these different programs all need to be able to communicate with each other. So ROS handles that for us in a very sophisticated way. ROS also provides a wide variety of useful software libraries and tools, and many of these libraries and tools are open source and available for us to use and play around with, which is excellent for developing our own stuff. So what are some example ROS applications? So one very big example is motion planning. So here's a recording of a robot arm being instructed to move from point A to point B, specifically in the shape of a square. Now the robot arm needs to be told what joint values it should take at every given instant. This is basically what motion planning is. Object detection. So this is taken from YOLO. You might have heard of it before. It's a real-time object detector. So in this case, it's finding a dog, a bicycle, and a truck all in the same image. So if your robot needs to be able to figure out where stuff is, super important. Just general computer vision. So if you want to analyze point cloud data. So in this example, it's analyzing the point cloud data from an Intel RealSense, looking at a fake hand in front of a checkerboard. So, a lot of robotics applications, you're going to need to analyze the point cloud data, figure out the shapes that you see. There's ROS tools and ROS software ROS-based software that can really help you with this. Task planning. In this case, there's a state machine here. We'll learn more about these in a later lecture. But your robot needs to be able to know what it should do at every point in time. So task planning is used to tell the robot what to do and when and what to do as a result of what it has just done. And communication with hardware. So Arduinos can act as nodes for ROS. So you can actually tell, for example, from your motion planner, you can then command a motor through Arduino to actually move to the right joint values. This is a video that was actually recorded in our own workshop of us while we were building our current robot arm. And of course, this is just the tip of the iceberg. There's so many more possible applications for ROS that I'm sure you'll learn about as you continue to develop new things. So yeah, ROS not only provides open source packages for all of these different things, but it also allows you to have these packages simultaneously communicating with each other in a simple, streamlined manner. Really, really helpful. This is a great example here. So this is a very good inspiration for this project, actually. You might notice the robot arm is very similar in design to our own robot arm. In fact, it's the same robot arm except for having one fewer degree of freedom than ours. But here you can see the arm is it detects a banana, and thus it knows that it needs to move the banana to the other side of the table than this apple. So you've got an object detector here, you've got motion planners, and you've got it all commanding the motor. So all of this is running in a ROS framework to make this whole process nice and streamlined. So yeah, excellent demonstration of the sort of thing that we'd be wanting to do in the robot arm project, and something that's very achievable actually. And this is exactly the kind of stuff that this lecture series will put you on the right track to doing yourselves. Credit to Jesse Weisberg for this. He's a really big inspiration for this project. So yeah, unfortunately, however, ROS is quite particular on the operating system on which it runs. You're going to need to run it on Linux, specifically Ubuntu, specifically further Ubuntu Focal Fossa for this particular project. So we'll need to get some form of this running on your machine. But not to worry, if you've got a Windows or a Mac, we will go through setting up a virtual machine so you can have an installation of Ubuntu running in an isolated environment in your host computer, so you can still do ROS. There's other solutions to virtual machines, so we're going to be doing VirtualBox in particular. But for example, Windows Subsystem for Linux, WSL, if you're on Windows, or if you're using a Mac, then Multipass is a good solution. But those all have their limitations. And the nice thing about VirtualBox is it is like having an Ubuntu system on your computer. So that's, you get the full experience really. And everything should be available to you. Now we're going to go through downloading and installing VirtualBox and then Ubuntu. So I've already downloaded the VirtualBox installer here. So I have a Windows, so I downloaded from this link. I've also downloaded the Ubuntu 20.04 disk image, the desktop disk image. So this is what we're going to actually use to install Ubuntu on our virtual machine. Because when you create a virtual machine, it's first empty, and then you install an operating system onto it. So I recommend you install both of those things before continuing. Another thing, on PC, I notice now that new versions of VirtualBox actually require you to have Python installed on your Windows. So what I've just gone and done is I downloaded the Python installer. So there's the Python installer. And I ran that. So I installed Python, just click through the installation instructions. And then what you want to do is you want to load up Windows PowerShell. So Windows, you just look up Windows PowerShell. It will then come up. And then you want to type here, pi-m pip install pywin32. So you're installing pywin32 onto your computer. And that basically just installs Python so that VirtualBox can use it for whatever it needs it for. So that's an interesting thing, which might catch some people out. It definitely caught me out. But there you go. That's the solution to that problem. And then I've installed VirtualBox. So once you've done that thing with Python, if you need to, if you've got Mac or whatever, or maybe a different version of Ubuntu that you're putting VirtualBox on, then you can just sort of go through the installation of VirtualBox directly. Just click through the instructions, and then eventually it will install. And here we are, the VirtualBox manager. So what we're going to do is we are going to go new. Actually, what I should do is I should bring up here. Here we go. The VirtualBox installation guide from Linux Hint. This is quite useful. It's very useful. It's what we're going to be following. So let's see. We've got to about here now. So yeah, we're going to make a new machine. And then we're going to, let's say we're going to name it Ubuntu 20.04 LTS. Let's give it a name. And then let's just keep this folder the same as what it automatically, what the default is. The ISO image. We'll get to that in a second, I think. So that the type be Linux. and then the version is Ubuntu 64-bit. Then we click next. Yeah, we're going to install the OS manually later. So I would recommend at least 4 gigabytes of memory. So this is currently 2 gigabytes of memory. So let's pump this up to 4. So 4 gigabytes of RAM. And then let's just keep this on one CPU. And then 25, I'd say go for 30. 30 gigabytes. Yeah, I can create a virtual hard disk. So this is how much space you'll have in order to, how much storage space you'll have in your virtual machine. This is allocated away from your hard drive. Cool, and then finish. Okay. And now what we're going to do is we are going to go into settings. And then what we're going to do is we're going to insert the disk image. So this is basically the equivalent of plugging the USB into a new computer to install the operating system. So here we go. So choose optical disk. Oh, cancel maybe. Choose a disk. Okay, yeah, you want to choose a disk file. And then let's see, I think I downloaded it onto desktop. So here we go. So we're going to open this disk file. So there you go. So that's the thing that we installed from the Ubuntu website. Okay, and yeah, you can see that's the selected disk image. So we press OK. And yeah, there we go. Now we press start, and fingers crossed this works. So it's going to load up the virtual machine, but we're going to have to go through the installation for an Ubuntu operating system. Here we go. This looks like Ubuntu. So that's a good sign. Here we go. It take a little while. It's got getting everything ready for installation setup. Here we go. Right. I'm sorry if this is quite small on your screen, but I mean, it should be quite straightforward, I think. We've got the nice instructions here that you can follow through as well, which I've linked in the lecture slides. So we're going to install Ubuntu. I'm just kind of giving a demo of, so it should be English UK. Detect keyboard layout, asterisk, Y, no. So yes, you can use this for it to automatically figure out. So there we go, #. So now I'm going to say yes, and that means it's going to detect it as the UK keyboard. So continue. So let's say normal installation, download updates. Okay, press continue. Cool. Okay, so yeah, we're going to choose erase disk and install Ubuntu. Don't worry about this here. It's not going to erase everything on your whole hard drive. That just means it's going to clean out the thing that, like the space that's already been partitioned, which we did earlier, and fill it with Ubuntu basically. So yeah, don't worry about that warning. It's all confined to within the virtual machine. Yeah, so this should be fine. Okay, now we're going to choose a location. Here we go. It detects me as Guernsey. That's where I currently am. Okay, fill in some information. Chuck. CLOTE. Password. Here we go. Cool. That still looks good. Okay. Now we're just going to let it do its thing. So yeah, it should be fairly straightforward installation, hopefully. Of course, as I said before, there's other methods that you can use to get Ubuntu on your system. But the nice thing about VirtualBox is that it is like having a little mini computer in your computer. So other solutions may only have part of what you need. For example, WSL, Windows Subsystem for Linux, is great in many respects. It's very quick, very smooth, but it has issues with, for example, if you try and connect a USB webcam, that's not going to work as of yet. So you can't do any computer vision stuff because they don't have the drivers in the current build of WSL. I'm not sure what other stuff like multipass allows in that regard, but yeah, I know for a fact that it works in VirtualBox. Hello again. I'm back, and I let it install, and it all seemed to have gone perfectly smoothly. So I restarted after it prompts you to, so it'll say like remove disk and press enter. You don't need to remove the disk, just press enter. And yeah, it'll restart and bring this up, and here we go. Look at that. We've got a little Ubuntu running on our computer. Next, so this is just the stuff that pops up the first time you load up Ubuntu. It's like blah 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 blah, unimportant. Great. Okay, great. Yeah, here we go. So this is a build of Ubuntu on our computer. So the next thing we want to do is sort of familiarize ourselves with the system. So this is the desktop. We've got the taskbar at the side. There's applications here. So look at all these applications. It's all a bit small currently. Apologies for that. We're going to handle that in a sec. There we go. So I think the next thing we can do is install VirtualBox Desk Editions. Oh, hello. No. Okay. So when it says a new version of Ubuntu is available, would you like to upgrade? And it says Ubuntu 22.04. We do not want that. Say don't upgrade and okay, because that's going to give a version of Ubuntu that the version of ROS that we want to be using is not compatible with. So don't do that. It's annoying. Sometimes it just randomly asks you that, and out of habit you might click yes, click no for that pop-up. Unreleased software has been issued. We can do that later. Yeah, so what we're going to do here is, yes, the command line. Okay, so let's go here and let's look up terminal. Yeah, so if you go to Show Applications and search terminal, this will bring up the terminal. This is super important. We'll talk more about this in a little bit, but you're going to be using the terminal a lot. Let's just go through a couple things first to make our experience with using VirtualBox a little bit nicer, because we're going to want to make the screen a bit bigger and all of that stuff. So what we're first going to do is we're going to do sudo apt update. Sudo apt update. Press enter. So it's going to ask for the password. So sudo stands for super user do. It basically gives you like admin permissions when you run stuff, and this is basically updating the repositories that Ubuntu looks through when it searches for updates for each piece of software. So you can see there's been found some potential upgrades to a bunch of software on Ubuntu there. So that all worked fine. Okay, so what we're going to do here is do VirtualBox guest editions, and this makes things a little bit nicer. So it allows us to use a lot of useful features. So you can easily install it Okay. So we did sudo update. So what we're going to do is we're going to copy this. Actually, I'm not sure if copy paste has transferred yet. Let's see. This might copy. Yeah, no, okay. So we haven't gained the ability to copy paste between our operating system and Ubuntu yet. That's one of the things that we'll do eventually. So we're going to type sudo apt install VirtualBox guest dkms VirtualBox guest x11 VirtualBox guest utils for some longer. Here we go. Do you want to continue? Yeah. There we go. This may take a little while. When it comes to longer commands, you're going to want to be able to copy and paste them in because it can take a while. So we'll do that in the future. So once you've finished installing the guest editions, if you then power off your virtual machine, so you press the power button here and say power off, and then you load it back up again, you should have now gained the ability to increase the size of your screen. There you go. Okay, now that we've got guest editions installed, we can also activate copy pasting across the host machine and the virtual machine. So if we go to devices here, you go shared clipboard. It would typically say disabled, so click on bidirectional, and that would activate copy pasting between host and guest. So for example, I'm just going to type Ubuntu is awesome. There you go. Control C that, and now I'm going to do Control Shift V in the command line. But if you're outside the command line, it's just Control V, for example. And yeah, there you go. Copy pasting is now working. Furthermore, if you want to increase the size of the font in terminal, or maybe inside the text editor or whatever, if you right click on here and you say preferences, it'll come up with the preferences settings. If you go text and then you select custom font here, you can then click and I would keep the font monospace regular, but you can increase the size. So I've increased it to 16 point here, which should hopefully be much more readable for you guys going forwards. Okay, so now what we're going to do is we're going to give a little bit brief introduction to the command line. So the command line or terminal, it's a text-based interface that you can use to control your computer. So rather than clicking on graphical, buttons and icons and stuff, you do everything by command line. And with what we'll be doing, you'll be using it a lot. So I'd recommend getting a lot of practice. So we're going to start that now. So what we're first going to do is we're going to go to the show applications here. We're going to select terminal. Actually, I'm going to just drag it into favorites. Let's put it there. There we go. So that means we don't need to go to applications every time. So we can go on terminal here. And what we're now going to do is we're going to, this little squiggle means that we are in the home directory. So what we're going to do is we're going to type cd documents, and we're going to press enter. And what you can see is that we've gone from tilde and then slash documents. So what this is represented by is this is our home folder here. And what we've done is we've changed our directory in terminal to documents, because the command line is dependent. It operates depending on which directory you're currently in the command line. So currently we're in the documents folder here. So tilde slash documents, and CD means change directory. So now what we're going to do is we're going to make a text file. So we're going to do nano hello world dot text. So hello underscore world dot text, and press enter. And now we've started making a text document. You can see here. So this is an empty text document. So what we're going to do is we're going to type hello world exclamation mark, and then we're going to exit. So we're going to do control X, and then yes, and then enter. Look at that. Hello world.text. So we can see the text file and then our little writing there. Cool. So yeah, to read the contents, you can if you want to read the contents in the command line, you can do cat hello world.text. There you go. Hello world. Note, if I do cd dot dot, so that means cd dot dot means to go back out by a directory. So basically to go, in this case, to go from documents back into home. So you're going back up the branch of directories, sorry, the branch of folders. And now if I type the same thing, so cat hello world, look, no such file or directory. So as I said before, the stuff that we can do in terminal depends on the directory that we're at. So there's no hello world.text in the home folder, but there is inside the documents folder, which is inside the home folder. So there you go. CD documents to go back to documents. And now we're going to do nano hello underscore world dot text. So we're going to do that again and see it's already got saved what we did previously. Hello world. This is an edit. So control X to exit, Y for yes. So you press Y if you want to change or save or whatever, and then you press enter to confirm. And let's see, now we load up here. Hello world, this is an edit. Great. So let's go and create a folder. So we're going to go mkdir, so that means make a directory, my folder. There you go, there's my folder. Inside documents. And now we're going to type env, so move hello underscore world dot text. So that's the file that you want to move, and then you specify the place that you want to move it to. So my folder. There you go. Ta-da! It's disappeared and it's and now it is inside my folder. Note, this mv hello world.text my folder. These objects are defined relatively. So if we wanted, we could have done this operation all the way from the home directory, but then what we'd have to do is we'd have to say move ~documents/myworld.text and then ~documents/my folder in order to define what these things are relative to where we would currently be. So there you go. So from home, we'd have to say and then ~doc. Yeah, like dot dot dot, like etc. 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 Okay, so now to finish off, let's clean this all up. So let's say cd my folder. Well, actually, let's go cd documents/my folder because we're currently in the home directory. There we go. So now we're currently inside here. And now we're going to say rm hello underscore world dot text. Yeah. So there you go. Remove hello world.txt. The RM deletes the file basically. And you see it's been deleted. And now finally, cd dot dot. So now we're going to go back out into documents and we're going to say rm slash hyphen rd my folder like that. And now the folder's been deleted as well. So now we've cleaned up all of the new stuff that we've made. So we've got a nice empty documents folder. There you go. So now the folder's been deleted as well. So that was a brief introduction into the command line and what you can do with it. But of course, there's so many very useful commands available for the terminal that you can use to do all sorts of different stuff. So we covered some of the basics. So we learned how to navigate between folders. So CD and then the relative folder path. Relative to where you currently are in terminal. You can also navigate to a specific directory from home, for example. So if you go, so home is represented by this tilde. You can then say home / and then the entire directory relative to home. If you want to maybe select something that's in a completely different region to where your directory currently is. So if you're currently in documents and you want to get something from, I don't know, downloads or something, it might be easier to actually specify it from home rather than from where you are in terminal currently. You can open files you can read files using cat, then the name of the file. You can create a folder using make directory or mkdir. You can use nano, as we saw, to create and edit files. You can copy files using cp. So then you specify what your source file is, and then you specify the location that you want to copy the file to. You can also move files. So mv, I think we covered that in the example. You can then move the file into the target location as well. You can copy entire folders if you do cp and then r and then the source folder and then the target location. You can then delete files using rm, as we saw already, and you can also delete folders. This is just a very small selection. I really recommend having some practice with bash scripting. In fact, I think I'm going to make that your homework for this lecture, or part of it at least. I really recommend playing around a little bit with command line, getting familiar with it, because you don't want to be worrying about learning to use command line while you're doing your robotics development stuff as well. So you want to already be nice and comfortable with using command line by the time you start, developing a robotic system. So this is a good link to that gives some good practice and information. But yeah, just have a play around with it. One last thing: when you do run a command, a lot of the time it's going to provide some really useful output text saying what's happening. Often it says nothing, which is actually sometimes a good sign, because if you run a command with a typo, terminal won't really know what to do in that situation, so it will bring up an error. Building on this, don't blindly enter commands without always checking to see what happens. If you run a typo, you should always first check for typos before you enter a command. But sometimes you might not even notice it even after you've checked, and it will bring up an error. Or you're trying to run a perfectly valid command in isolation, but maybe something else is going to prevent that command from doing what you want it to do. Maybe you lack the package that you need in order to run a specific command, and that will throw up an error as well, probably in red, but and you should always check for typos, and you should always sort out any errors that pop up. I know this sounds almost patronizing, but this is a really important practice, and I've seen a lot of people completely neglect this. I once spent like half an hour helping somebody who themselves had spent like an hour trying to figure out why their ROS installation isn't working, only to scroll all the way back in terminal and find that the very first command that they ran had a typo in it, but they didn't read the result of that command, so they didn't realize it went wrong. Then they proceeded to do a bunch of other commands, but none of them worked because the first one didn't work. So please go step by step, be careful, and make sure that everything is working as it should. every time you do a command. Oh, and another thing on this, Stack Overflow and other resources are really online resources are really good for sorting out all sorts of problems. There's been countless bugs and errors that I've experienced that were solved just by giving a giving a search on the internet. So learn how to look up how to solve these problems as well. That's part of software development, really. Learning how to look for solutions on the internet, and that just takes practice. So, in summary, we've covered an overview of what ROS is. We went through installing VirtualBox and then Ubuntu on the virtual machine, and then finally we looked at the command line. So your homework is to finish setting up Ubuntu and get it working nicely. And I would also say to get some practice with the command line. Maybe just do some basic stuff, or maybe try to follow some tutorials on the internet of getting familiar with using it. So next time we're actually going to install ROS itself, and we're going to start using it. So that's the end of the first lecture. Thank you for watching, and I'll see you on the next one. Goodbye.